Okay, so in this video, I want to do 9 and 10 together. So look at number 9. You have the constant function. You have the cosine. First, you stretch it out by 2, and then you add by 1, right? So the constant term is 1, and the coefficient in front of cosine is 2. Look at example 10 real quick. In example 10, we've actually reversed these guys, okay? In this case, you're not stretching it cosine out by 2 at all. You're multiplying that by 1, and then you're adding 2. So we've interchanged the 1 and 2 in example 9 and example 10. And we want to sort of investigate what happens when you do that. Okay, so when I go to graph my cosine graph this time, I'm going to graph it a little bit differently. I'm going to label every block as just one increment. So it's not the same scale as we had in our earlier examples. So cosine is still goes from 1 to 0 to -1, back to 0, back to 1. So our regular graph cosine is going to look like this. Okay. And then what is this 2 in front going to do? This 2 in front is going to stretch it vertically by a factor of 2. So really, when I go to graph this guy, maybe this looks... When I stretch it out by 2, maybe 1 times 2 is 2. 0 times 2 is 0. -1 times 2 is -2. 0 times 2 is 0. And 1 times 2 is 2, like this. So then when I stretch it out by 2, I get this graph. Right? So this graph is r is equal to 2 cosine theta. Right? And then when I add 1 to it, what does it do? When I add 1 to it, it just shifts everything up by 1. So this guy shifts it up by 1. This guy gets shifted up by 1. This guy gets shifted up by 1 to there. This guy shifted up by 1. This guy shifts up by 1. So in the end, I get this graph. And this blue graph right here, this is r is equal to 1 plus 2 cosine of theta. Okay. So I'm going to delete all these green graphs because it looks kind of messy. Okay. So you get rid of all that. Let's just worry about the graph we want. Okay. So when theta is equal to 0, how far out do I go? I go at a distance 3. 1, 2, 3 is right there. Whoops. 3 is right there. Okay. Next, I go at a distance of pi over 2. Pi over 2 is going this direction. Pi over 2. How far out do I go this time? This time I go out at distance 1. Distance 1 is right there. So somehow, as I swing around from 0 to pi over 2, I'm going to get the radius decreases all the way down to 2, like this. Okay. And then what happens? So this next part is where the really interesting stuff happens. Okay. But this next part, it looks like this. This part. And let's look at what happens when you face the pi direction. So the pi direction is facing this way. And when you look, this means that I go behind myself. That means when I'm facing that way, if I go behind myself, my point is going to be there. But let's look at this action. What's happening is I have a radius of 1. It decreases. At some point, the radius hits 0. So this radius decreases. At some point, it hits 0. And then I start going behind myself. So the part I'm going behind myself is from here to here. This part I'm going behind myself. So that part kind of goes like this. Okay. So, and then when I do the next part, I'm still behind myself for this first part, but then I go back to 0. So it's sort of like, oh, I'm still behind myself, but I go back to 0. Okay. And then by the time when I hit pi over 2, when I'm facing the pi over 2 direction, I've gone out a distance 1. So I'm facing the pi over 2 direction, 3 pi over 2 direction, and I end up a distance 1 on the outside. So it comes around like this. Okay. So we delete this. And we delete this. Okay, so what about the last leg? The last leg is not that complicated. So we're starting off at distance 1 away, and when I'm facing the 2 pi direction, I end up at distance 3 away. So then this part goes from distance 1 away, expand, expand, expand out to distance 3 away. So in the end, this is the graph that I get. And this graph is called a limaçon. Oh, I think it's French. Limaçon with a little accent there with an inner loop. And when does this happen? This happens when you have r is equal to a plus b cosine theta, or r is equal to a plus b sine theta. When you have b is greater than a, that's when you get the limaçon with an inner loop. This video has gone on long enough, so I'm going to stop it.